Number 7, we need to continue to simplify with addition and subtraction of square roots. I can only actually squish 2 square roots into a single square root expression if I have identical roots. None of these are identical, but they aren't simplified yet. So it's time for simplification fun. I'm going to start with the square root of 50. And I'm going to write a 50 over here, and we are going to look at factor treeing that number. 50 is even, so I'm going to put 2 times 25. And maybe you recognize 25. Hey, that's 5 squared. Or you factor further, whichever. So every couple in a square root gets square rooted and gets merged into one entity. I have left over a 2. You could say the 2 survived the squishing into one being and leaving your personal persona at the doorstep as you merge with the other. All right, 75. Let's break that down. It's not even. It ends in a 5, so it is divisible by 5. And you're familiar enough, hopefully, with money where you can think, that's 3/4. 3/4 makes 75 cents. Wait, I just realized that means 25. Maybe that's the way you see it. If you divide by 5, you can always use a calculator if you need to. And that's going to give you 15 if that's the way you do it. But however you do it, you're going to wind up with 2 5s and 1 3, no matter how you break it down. So I've got a couple. Oh, look at the cute couple. They're going to come out, be merged into one entity. And then the one that didn't couple up gets to keep itself as it is. Now, I want to make sure you're clear where I'm at. This minus sign went here. And now we're at this plus sign, which I'm going to put here. And now we're going to break down 98. And anything that comes to mind that you know divides 98, use it. It's even, so I'll divide it by 2. You can use a calculator. That's going to wind up being 45 plus 4, so 49. Maybe you recognize 49. It's a perfect square number. The 49 can have its square root taken, and the 7s merge into a single 7 when I take the square root. The 2 stayed single, so it stays as is. Ooh. So, while you're young and you don't want to have your identity overtaken, don't merge into couplehood. Stay single. Your parents will prefer it. They can worry less. Sorry. Just throwing that. Yeah, never mind. But actually it's a pretty good description of when you do couple up with someone, you do have to merge to some extent. All right, plus. Now I've got 27. Breaking 27 down, it's 3 times 9. Maybe you recognize that 9 is a perfect square. The square root of 9 is 3. And 1 left over 3. Whatever you need to do to simplify these square roots, do it. You don't have to go about it in the same way that I'm doing it. You're kidding me. We only have 10 minutes left? Do we really only have 10 minutes left? Wow. Okay. Well, I know that I spent the time well because you needed that slow process explanation. Not all of you needed it, but I know enough of you did. Now, let's look at what we have. I've got a root 2. I've got another root 2. Those can combine. I have a root 3 and another root 3. Those can combine. For the root 2's, I have 5 root 2's, and I'm adding 7 root 2's, so I have 12 root 2's. For the root 3's, I have negative 5 root 3's plus 3 root 3's. Negative 5 plus 3 is negative 2, so I have negative 2 root 3's. And that is then the final answer. I'll write it in one color. And you cannot add or subtract those two rational or those two root expressions because they do not have the same number under their square root. Okay, continuing on. Now, exponential decay. I'm going to have to do this faster than I really wanted to, but we did do growth already. So I'm going to show you that you have answers attached to your classwork. Some of you have already done this and turned it in. This is what we wind up getting. And I want you to do this on your own before you turn this in. But you can see that you've got all the answers you need. But think about what you're doing. Now, this is a specific exponential decay. Decay happens when the base number is between 0 and 1. The problems that I'm going to give you, I'm only going to give you fractions where the numerator is 1. And what I want you to see is no matter what the base is, even if it's growth, it goes through this point. They always go through the y-intercept of 1 because it doesn't matter what the base is, with one minor exception that we're not going to talk about. Doesn't matter what the base is. If the exponent is 0, you're getting 1 out of it. But when that base is between 0 and 1, it decays as you head into those positive numbers instead of growing. If you want a second point, you can stick with the idea that I gave you before, which was when x is equal to 1, y is equal to whatever the base is. But it's not, people don't tend to like to plot fractional numbers. I don't. So if I'm always giving you 1 divided by a number, here I gave you 1/2. Maybe I give you a base that's 1/3 or 1/4. What I want you to see is if you put -1 in, so this one was 1/2. If you put in -1, that negative exponent says flip that fraction, and then you've got a nice number. In this case where it's 1/2, you're getting 2. If I had given you 1/3 to the x, then you would plot the point -1, 3. and you can get your second point without too much work, and just understand these issues. And I need to then go over here. I need you to draw this graph on your own. The important points are the intercept of 1, and then you can choose which of the other 2 points you prefer. Do you prefer plotting a fraction, or would you rather flip your fraction? And that 1 over b is going to end up being, so for example, if it's 1/3 to the x, 1 over 1/3 is 3. So if I'm giving you 1 for the numerator every time, then you can plot the point -1 and then the denominator, basically. And by the way, you thinking in this manner is prepping you for logarithms. If you think a negative exponent means reciprocal, that's going to help you out. Now, I wanted to get to explaining to you this extra bit here, but I have run out of time. So, I'm going to do a video during lunch, and I'm going to post it, and I need you to watch it. Unless you feel like you understand what is stated here, I need you to watch it. And I need to get you onto the quiz.